In this video, you will learn how to simplify square roots and nth roots, including variables. First, let's recall a few methods to simplify square roots. In this case, we are doing the square root of 18. The radicand 18 is the same thing as 9 times 2. The reason I broke it down into 9 and 2 is because 9 is a perfect square. The most efficient way to simplify a square root is to figure out what is the largest perfect square factor of the radicand and break your radicand into that value and whatever factor remains. Since we know the square root of 9 is 3, our answer is going to be 3 root 2. A different way to do the same process, but will look different visually, is to write 18 as 3 squared times 2. By writing the radicand as its factors squared times whatever is left, we can then see that since there is a square root of 3 squared inside, we can write a 3 as a coefficient, and since 2 is not squared, it will stay in the radical. You again could have chosen to split these into the square root of 3 squared times the square root of 2 if this helps you to visually see it. A third way that we've learned is a factor tree. This is not an efficient method, but it will work if you like something that's systematic. So we see that 9 is 3 times 3, and we still have a factor of 2. So since we have the square root of 3 times 3 times 2, and I see a pair of 3's, I can write the 3 on the outside. Now we're going to apply this to both variables and higher indexes. Let's look first at variables. So the square root of x squared, well, it's a little bit intuitive, but that is just x, because the square root and the squared cancel. Similarly, you could have written it as the square root of x times x and seen that there was a pair of x's inside. Now a quick technicality, the answer to this is really the absolute value of x. You can watch another video to learn why this is and when we need absolute value symbols, but for the purpose of this video, we're not going to talk about that rule. Then we have the square root of x to the 6th. Well, since x to the 6th is something squared, in fact, it's x to the 3rd squared, this square root and this squared cancel. So the answer then is just x to the 3rd. You could have again written out all 6 factors of x. If you chose, you'd see that we have 1, 2, 3 pairs of x's, and you can write one on the outside. The square root of x to the 9th is a common mistake where we see people take the square root of 9, but that's not the case, because this is x to the 4th squared with another x that isn't squared. Therefore, we're going to have x to the 4th on the outside as a coefficient and one more x left inside. If you were to write out all 9 x's, you would circle 4 pairs of x's, but you would still have one left over in your radicand. As we get to higher and higher exponents, we want to look for a pattern. In other words, if we divide this exponent by the index, that will tell us whatever our exponent is left. So for example, since we're looking at square roots here and we have x to the 6th, 6 divided by 2 is 3. 9 divided by 2 is 4, with a remaining 1 inside the radical. So when we're given a problem to simplify that has a radicand including variables and coefficients inside the radical, we simply do our process for both of them. So one way to do this would be to write the square root of 20 as the square root of 4 times the square root of 5. And then we have the square root of x squared times the square root of x. Therefore, since I see perfect squares here, I will have a 2x on the outside as a coefficient, and I will still have a 5x left inside. You may like one of the other methods better, so you may write this as 2 squared times 5 times x squared times x to get your same result of 2x root 5x. Or you may have even written out every one of your prime factors, 2 times 2 times 5 times x times x times x. This is visually a good way to start, but it's not a very efficient method as you get into larger indexes and higher exponents inside. The same principles will still apply as we get into higher exponents, as I've said, and you don't want to be writing out all of your x's or always going to prime factors. You want to figure out what is the largest perfect square or perfect cube or perfect fourth power that goes into your radical. So when I see x to the 7th in my radical for a square root, I should, in my head, be able to figure out that this is x cubed root x. If you're not sure why, it's because the biggest perfect square inside this was x to the 3rd, but we still had one remaining x factor inside. When I see the square root of x to the 103rd, I need to use the same process. So I need to say, what is the biggest square inside of my radicand? And that would be x to the 51st. But I would still have another x left over, because 51 times 2 is 102, which means that I still need one more x to get to 103. So my answer when I simplify this is x to the 51st root x. Again, you're really dividing your exponent in the radicand by the index. When you get to higher indexes, such as a cube root, again, the same principles apply. 54, I know, is 27 times 2. I would always think about what is the largest perfect cube factor that goes into 54. Then I'm looking for cubes for x to the 6th. Well, x squared cubed is x to the 6th. Then for my y's, I have a y cubed, but I still have 2 more y's left over. So if I look, I have a perfect cube 27, which gives me a 3 as a coefficient. I have a perfect cube x squared, which gives me an x squared as a coefficient. And I have a perfect cube y cubed, so I'll have a y on the outside. When I write my radical, I have to remember the index. This is very important and frequently forgotten. And I still have factors of 2y squared left inside. So here's my answer. 3x squared y times the cube root of 2y squared. The last example I'll do with you today is the 6th root of x to the 12th, y to the 50th. Again, you want to try to do this with mental math if possible. So when I see the 6th root of x to the 12th, 12 divided by 6 is 2. So I know that I'll have an x squared on the outside. The reason for this is that we have something to the 6th inside. And when we're dealing with our x's, we use all of them. We have x squared to the 6th in the radicand. With y, 50 divided by 6 is 8, so I will have a y to the 8th on the outside. And whatever the remainder is will go inside, which in this case is 2. That's again because I'm looking for my y's something to the 6th. The biggest factor of y's that I can put in there is y to the 8th, but I still have another y squared that's left over and still in my radicand. So my answer is x squared y to the 8th times the 6th root of y squared. I hope you found this video helpful in how to simplify square roots and higher roots such as cube roots, fourth roots, fifth roots, etc. with both numbers and variables.